In today's lecture, we try to find out another algorithm which is called round robin algorithm. In the round robin algorithm, actually what will happen is every process which come into the ready queue will be given a time quantum. Okay, and once the time quantum is finished, we'll take out the process from the CPU. So this is how we do this type of scheduling algorithm, and we'll do the process on that particular type of scheduling algorithm. So what I told you is we'll give the time quantum. So here in the round robin algorithm, let's talk about the round robin algorithm. So in this round robin algorithm, we have round robin CPU scheduling. Round robin CPU scheduling algorithm. So in this particular type of algorithm, we have main criteria based on that this scheduling will be taking place. So the criteria is the time quantum. So every process will be given a time, and within that time they have to execute in the CPU. Once the time is finished, they have to uh, forcefully taken out from the CPU and again put into the ready queue. And this particular algorithm is of preemptive type. So the criteria for this algorithm is time quantum, and it is a preemptive type scheduling algorithm. Okay. Now let's talk about its process, that how this algorithm works. So we'll see about its process and we'll see how this algorithm takes place. So this particular algorithm will follow a process. What is a process? Let's say some process is in the ready queue. So some process is in the ready queue or in the ready state. It will go to the CPU when we select it. So the CPU scheduling algorithm will select the queue. So let's say the process are in the ready queue and CPU scheduler will select a process. From where it will select? From the ready queue. And after that, after selection, selection for the processing, right? So it will be allocated CPU. Now once it will be allocating the CPU, what will happen is this process will be having the burst time, right? Now the burst time of the CPU, if it is less than the time quantum, then what will happen? Let's say the time quantum is 4 and the CPU burst time is 3. So it will execute within that particular time quantum, right? So it is less than that. So if the time quantum is more and burst time is less, or you can say the burst time is less than the time quantum, if that criteria meets, then that process will go to the terminate state. How it will go to the terminate state? Once the execution will be finished, as well as time content is also not finished. At that particular time, the process will go to the terminated state. If let's assume that the time quantum is less and the burst time is high, let's say the burst time, some process is taking 10 burst time and the time quantum is 4. At that time, what will happen? That process will execute 4 burst time as the time quantum permits. And after that, because that criteria doesn't meet, so it will go to the no part. After that, it will be executing into the CPU. If that criteria doesn't meet, then it will execute into the CPU. And then once the time quantum expires, it will go to a condition, and that condition is the process execution completes. Process execution completes. If it is complete, if yes, then it will go to the terminate state. Otherwise, if it does not terminates, then again it will go to the ready queue. So if we'll take one example, let's say we have a process P1 and P2. Let's say process P1 has burst time, let's say the burst time is, let's say 10, and process 2 has a burst time, let's say 3, and your time quantum, let's assume that we have 4 unit of time. Now both processes are in the ready queue. Then we'll select a process from the ready queue. Here what we do is, in which way we'll select? We'll select based on first come first serve criteria. So we'll select in a first come first serve basis. So let's say P1 is the process 1 which came first. So P1 will go into the ready, it will select and go into the CPU. And just before finding out into the CPU, what we see that the burst time of that particular process is less than the time quantum. If it is, then after the process, it will go to the terminate state. So we'll do it here. We'll write it is yes. Then after the processing, it will go to the terminate state. If burst time is not less than time quantum, means the 10 is the burst time, definitely 10 is not less than 4, then what will happen? Then it will execute into the CPU up to the time quantum expire. Once the time quantum expire, means at 4, the time quantum will expire, it will go to another condition. It says that the process execution completes. The process execution does not complete. Why? Because the burst time here, it is 10 and we have just executed 4 burst times, so 6 is left. So the criteria will be no. If it is no, then again it will go to the ready queue. Now after that, which process will come? P2 will come. Now once the P2 will come into the system, it will find it out the burst time of the P2 is less than the time quantum or not. So burst time is 3, it is less than 4, yes. So after the process or after the CPU time, it will be terminated, right? So the termination will take place. So there will be no coming back of P2. Now which one is left? So again P1 is left. So P1 will again come into that particular system P1 will execute. What is the remaining bus time here is 6. So 6 is less than 4? No. Again it will execute. Again after the 4 CPU time, it will be checked whether it is completed its execution or not. So because now 2 is left, so you can see previously 6 was left. After that 2 is going to left. So because 2 bus time is left, again it will go to the ready queue. Because we have only one process in the ready queue, again P1 will be picked up here, and again the process will take place. This time the burst time is less than the time quantum. Definitely it is less than that. So after the processing of that, we'll just terminate it. Means after that 2 burst time, it will be terminated. It is not going to wait for the time quantum. It will just execute its burst time and then terminate. So this is how this round robin algorithm took place. Okay, so you might understood this, how this process will go on. To understand more, let's do some exercises and let's do and find it out some of the problems. So let's see problem 1. We have process number, we have arrival time, and we have burst time, right? We have another thing that is given is time quantum. So the time quantum for this particular problem is 2. 2 is the time quantum, means up to 2 unit of time we are going to execute. Now let's write down the process 1, process 2, process 3, process 4, process 5, and process 6. So we have 6 number of processes that are available. Now what is the arrival time? Arrival time is 0, 1, 2, 3, 4, and 6. So the last one is 6. Now what is the burst time? Burst time is 4, 5, 2, 1, 6, and 3 are the burst time of these problem. Now what we have to do? We have to use the round robin algorithm for that. So we'll use round robin CPU scheduling algorithm here. Now for that, what we do is we'll just see, we'll create 2 things, right? So first we'll create the ready queue. And second we'll create the Gantt chart. Gantt chart will tell us that in CPU what is the status, and ready queue will tell us in main memory what is the status. Okay, so let's draw this and let's draw this also. Yeah. Let's do that now. So our time quantum is 2, which is given here. Now let's talk about time 0. At time t0, how many processes are there in the ready queue? So we have only one process, that is process 1 will be there in the ready queue. So if process 1 is there in the ready queue, so definitely process 1 will be executing first because it is a first come first serve, but we have a time quantum on it. So P1 is coming here. Now we have to execute P1. Once the process came into the CPU, how much time we have to give to the process? We have to give 2 unit of time because the time quantum is 2. What is the burst time? Burst time is 4. So if we'll see this particular algorithm, if somebody is in the ready queue, we have to select it. So definitely at time t0, p1 is the one option. We'll see its burst time is less than the time quantum. So what is the burst time? Burst time is 4. 4 is less than 2? No. Then it will execute in the CPU till the time quantum expire, right? So we have to execute it till the time quantum expires. So what is the time quantum? Time quantum is 2. So it will execute up to 2. Now after that, what will happen? Now let's see so P1 is here, right? So we'll remove here P1 at that particular time, and P1 is executing here. Now at time T2, what is the status? Now while it is executing at time T1, P2 came, and at time T2, P3 came into the system, right? Now at time T2, this is the thing. We are not preempting it right now. This is the thing. So P1 is here, P2 is here, and P3 is here. Now, because the time quantum is finished, according to the round robin algorithm, once the time quantum is expired for a particular process, it has to go to either into the terminate state or into the ready queue. It will go to the terminate state once all the execution burst time has been expired or the process has done its execution. If process hasn't done its execution, it will go to the ready queue. So here, because process P1 has completed its 2 burst time, so 2 is left. So it will not go to the terminate state. Instead, it will come into the ready queue again. So this is the status at time T0. Now, after that, which one will go? Is a first come first serve criteria, right? So your queue is just like a first come first serve. So in queue, what will happen when we go for the tickets and when we in the queue? So whoever will come first, definitely he'll get the ticket first. In the same way, the queue is also working. So who is in the rear side of the queue? So front sides of the queue. So P2 is in the front sides of the queue. So P2 will get the chance into the CPU. So we'll remove the P2 from the ready queue and we'll put into the CPU. So now P2 is here. Now, how much time this P2 is going to take? So definitely it is going to take 2. How it will going to take 2? Because its burst time is not less than time quantum. Its burst time is 5, which is not less than time quantum. So it will just take 2 unit of time. Means at 4, it will be up to 4 it is going to execute. So at time 4, how much more process will come into the CPU? So you can see at time T3, P4 is coming, and at time T4, P5 is also coming into the ready queue. Now, once this is expired, we have to see how much process is left here. So how much, burst time is left for the process. So again, here 3 burst time is left. So because there is some left burst time, we have to put it into the ready queue. So P2 will come here. We'll remove P2 from here and it will come here. Now after that, which is going to execute at time T4? So it is going to execute, P3 is going to execute because P3 is in the front of the queue. So P3 will come here. Now once the P3 will come here, it will execute up to 6, again 2 burst time. And we'll see whether burst time is less than the time quantum. No, burst time is not less than time quantum. So it will execute itself for up to time quantum. Once it will execute, we'll see whether more execution is left on that or not. So we'll find out that there is no execution left. So P3 will be terminated. Now P3 will be terminated and it will not go into the CPU again. But at time T6, you can see here, Another process is taking place into the ready queue, that is process 6, which is coming into the ready queue. But P3 is not going into the ready queue. Now process 3 is terminated. So you can see in the termination state. So I'll just write here. So here I'll write somewhere. So which are in the terminated state right now? So P3 has already been terminated. Now this is the position of ready queue at time T6. Now which is in the front? Front is P1. So P1 will get the chance to be into the CPU. Now P1 will going to execute another 2 quantum of time, because burst time is not less than time quantum. So it will execute, and then we look for the how much process burst time is left. So for P1 also at time 8, it will serve here 2 and here 2. The total burst time was 4. It has already been done. Now it will go into the terminate state. Done. Now after that, we are not putting back, right? Now after that, P4 is in the front. So we'll take the P4 into the CPU. We'll execute P4 at 2 time quantum. But before that, we'll see that burst time is less than time quantum or not. So here burst time is less than time quantum. So it will not look for the time quantum expiration. It will look for the burst time of the CPU. Sorry, the process. The burst time of the process is less than the time quantum. So it will execute the burst time into the CPU, and after that what it will do is it will execute it, and after that this process is going to be terminated. So here it will be 0 and your process is going to be terminated. And so in the terminated state, P4 will also come here. Got it? Now P4 is done. Now go to P5, because P5 is in the front right now. So we'll take the P5 here. So it will be executing up to 9, right? Not up to 10, because we have only one burst time. So P5 will come here, and P5 is getting chance into the CPU. So P5, how much process burst time is left for that particular process? So 3 burst time is left. No. Yeah, 6. So 6 is less than 2. No, 6 is not less than 2. It will execute up to time quantum, and the remaining burst time will be 4. Because the remaining burst time is 4, it will be again taken into the ready queue. Got it? So at 11, it will be again taken into the ready queue. After that, P2 is going to be executed into the CPU. So what about 2? 2 has 3 burst time left. So definitely it is not less than the time quantum. So how much will be left? 1 will be left, because 1 is the execution time that is left. So again, at time 13, P2 has to go into the ready queue, right? Now, which is in the front? P6 in the front. So we'll take the P6 and we'll allocate the CPU here. P6 is executing again, because the burst time is 3. 3 is less than 2, no. So P3 is going to, P6 is going to execute for the time quantum up to 15. And again, we'll check whether it has been executed fully or not. So we'll find out it is not executed fully. 1 is left. So we'll again put the P6 into the ready queue. Now after that, which is in the front? P5 is in the front. So we'll take the P5 and we'll allocate into the CPU, and it is going to execute for another 2 unit of time. because P4, 4 is left. So after that, 2 is going to be left. And at 17, it will be taken out from the CPU and put it back into the ready queue. Now, which will go? So P2 is, because P2 is in the front, so P2 is going to be execute into the CPU, and we'll put P2 here. Now P2, let's go and find out the burst time of the P2. What is the burst time of the P2? The burst time of the P2 is only 1. So because burst time is less than 2, it will execute itself and terminate. So it will execute itself and go to the terminate state. But it will not go to the ready queue, right? Because it is in the terminate state. Now after that, which is in the front of the ready queue, so P6 is in the front. So P6 is going to execute. So it will be executing at 18. P6 is going to execute. 1 is left only for P6. So it will execute up to 19 and it will be terminated. So P6 is going to be terminated. Now after that, only P5 is left. We'll put P5 into the ready queue. What is the status of P5? Because P5 is going to take 2 unit of time. So it will take 2 unit of time. Once the time quantum expire, we'll see how much is left. So we'll find out nothing is left. So we'll just execute it and then we'll terminate it. So it will execute another 2 unit. So at 21, it will be executed. So you see how this round robin CPU scheduling works, right? So this is how the status of the ready queue, and this is how the status of your Gantt chart. So this process is somehow complicated than the other process that we have seen till now, but this is the most interactive algorithm, CPU scheduling algorithm that we use nowadays, and almost all the operating system use this particular round robin CPU scheduling algorithm, right? And there are also some enhancement in all the CPU scheduling algorithm that we have gone through till now. So till now we have gone through first come first serve, then shortest job first, then shortest remaining time first, then priority based scheduling, and at last we have seen round robin algorithm. Okay. Let's find out its different timings. So what are the timing that we need to find out is here. We have to find out the completion time, turnaround time, and waiting time. So all these timing we'll find one by one. So let's go and see the first time, which is called completion time. Okay. So what is the completion time here is? Completion time of P1. So we'll start from the left and we'll see when P1 has been occurred. So you see P1 is occurring here. What is the completion time is 8. So we'll write 8 here. Now the second is P2. We'll start from the left. So we'll find P2 here. What is the completion time of P2? It is 18. So we'll write here 18. Now come to P3. We'll start from the left and we'll see when P3 is coming. So here we have P3. Completion time is 6. So we'll write 6 here for P3. Now go for P4. The completion time. We'll find out here. The completion time of P4 is 9. So we'll find out 9 here. Write down right here. Now come to 5. And the completion time of 5 is 21. So we'll write 21 here. And completion time of 6 is 19. So we'll write 19. Now let's find out the turnaround time. So what is the formula for turnaround time? Is completion time minus arrival time. So completion time is 8 of P1. Arrival time is 0. So turnaround time is 8. Completion time is 18. Arrival time is 1. It will be 17. Completion time is 6. Arrival time is 2. It will be 4. Completion time is 9. Arrival time is 3. It will be 6. Completion time is 21. Arrival time is 4. It will be 17. Completion time is 19. Arrival time is 6. It will be 13. Right. Now come and find out the waiting time. So the waiting time is turnaround time minus burst time. So turnaround time is 8. Burst time is 4. The waiting time will be 4. Turnaround time is 17. Waiting time is 5. It will be 12. Turnaround time is 4. Waiting time is 2. It will be 2. Turnaround time is 6. Burst time is 1. Waiting time will be 5. Turnaround time is 17. Waiting time is 16. 6. Waiting time will be 9. Turnaround time is 17 and 6. It will be 11. It will be 11. Now here the turnaround time is 13. Completion time is 3. It will be 10. So 10 will be your waiting time here. So you see, this is how we'll calculate the completion time, the burst time, and the turnaround time of completion time, turnaround time, and waiting time of all the processes. Now after that, we can find out the average waiting time as well as average turnaround time. Okay, so all those things we can find it out here. So the average waiting time will be 4 plus 12, 16 plus 2, 18 plus 5, 23, 23 and then it will be 34 and 44. So it will be 44 divided by 6 is your waiting time. Now the turnaround time will be 18 plus 8 plus 17. It will be 25. 25 plus 4, 29. 29 plus 6, 35. 35 plus it will be 35, 45, 55 and 60 divided by 6. So this is how we can find it out, the average waiting time and average turnaround time of all the processes. Now here also we can calculate another time which is called response time. So when a first process got the response, right? So that also we can find it out and we can calculate it. Now I think you understood the functionality of a round robin algorithm here.